Yeah, welcome to Secret K. Today we have HP 840G3. What this system does is that it charges battery, but it's not coming on. So let's measure together so you can see. How do I know it charges battery? On the data and clock, on the battery terminals here, you can see 3.3 volts, and we have that about in two places, and we have 12.4 here. We have 12.4. So this system is actually working and it's charging battery, but it's not coming on. So so let's troubleshoot together. Let's understand what the problem is. There's no power button here, but so I'm expecting the system to come up, the motherboard to come up, just by plugging the charging the charger to it, because the CMOS battery is disabled, but it's not coming up. So I'll have to check if we have the 3 volts 5 volt in place. So let's measure together. So here we have these are the units for 3 volt 5 volts. I don't really know which exact one is the 3 volts and 5 volts, but this is a section for 3 volt 5 volt switching. So let's check. Over here we have 3.4. Over here we have 0 volt. All right, so we have 0 volts here and we have 3.4 here. So so we have problem with the 5 volt switch. So this is a MOSFET that switch the 5 volt. So I think this MOSFET is bad, and if we look at it closely, it looks like someone else work on this IC. Someone else work on that IC, but I'm not sure. So let's switch to continuity mode and check that particular spot again. So right on the inductor, you can see you're hearing a beep sound from the multimeter. So there's a short with this IC, because this is on the output of this IC. This is on the output of this IC. So there's a short, meaning that the output of this MOSFET is shorted. Then on the input of this MOSFET, as you can see, the input is not shorted. That's why this motherboard can still charge battery, then not coming on. You understand? It charges battery, but it's not coming on because the input is open while the output is shorted. So without the 5 volts, this system will not be able to turn on, will not be able to process. USB will not work. The startup chip will not receive power. You understand me? So we'll go ahead and replace this. I have a second-hand IC. I have a second-hand IC, second-hand MOSFET. So I already have it here on my table. You know, I did the diagnosis before now. So this is the IC. This is the MOSFET. All right, so this is my second-hand MOSFET. So I will be replacing the MOSFET now. So let's see what the result will be. Don't know what your faith is. Do you believe it will work? All right, so all right. Okay, IC in place. So we'll leave it for a while, let it cool down. So just leave it for a while. Alright, so let's test. It's very important to measure after replacing the IC because you're using heat to replace it. Anything can go wrong. You see, so I think let's have a proper ground. As you can see, that channel is open. That channel is open, meaning that we no longer have a short. Okay, on the inputs there is no short, and on the outputs there is no short. So we are having a perfect working IC on that position there. So I believe everything will work. So let it cool down a bit. All right, so I'll come with the charger, plugging in. All right, you can see the system is on, but first we need to measure. On that part, remember we have 0 volt. So let's see what we have then right now after replacing the IC. So we have 5.4 volts now. So this board is 100% fine. I'll be checking the display since the screen is not here. So I'll be using my keyboard to test the display. Let's plug in the charger again. Okay. So if you have our cap lock here, mean that the system is fine, then the board is coming up and the display is good. Why did it? The fan is running. Okay. All right, so you can see the num log is on and the cap lock is on. So everything is fine. If you find this video helpful, do well to like and subscribe. Thanks for watching.